Hello, my name is Rez, and I'm a professional game programmer, and I do electrical engineering as a hobby. And we're doing the Robot Advent Calendar for 2024. This is day 4, and we're doing the technical video. So, okay, I want to talk about a few things. The first thing I want to talk about is this LED. It's a fun little device. Mostly they just turn on, and they don't do what this guy's doing. Normally you get something like this. I'll turn this off. We'll put in another one. This one I'm putting in, this one's a green one. So the green one is just, this is your basic run-of-the-mill LED. Normally it just does this, right? It just turns on if there's power applied. Ours has a little fun, I can't see it, and there's no way that it's really going to pick it up. I'm going to see if I can get this to focus a little more. I don't think I'm going to be able to. Oh, there it is. You can kind of see it in there. You can't really see the chip. Yeah, there's like a reflective surface in there. You can see kind of what's going on in there, but there's a little chip that does the actual timing. So that's what's going on with this one. Now, I have a much better view of this, and this much better view comes from a book called Open Circuits. Pull this up so you can get a better view of it. Here it is. So this is Open Circuits by Eric Schleipfer and Wendell Oski, and I'm definitely butchering those names, so I apologize for that. But I'll zoom right in on their names. You can see it there. I recommend this book. It's a really good book. It's just a bunch of really, much like the cover here, very high resolution photography. There's some diagrams in there, but all of the images, there's no like 3D recreations. It's all just really high resolution photography. So if we open it up to the LED page, so we can kind of see what's going on here. We've got the anode. So there's two terminals, these two leads here. I'll use this green one as an example. There's two terminals. This longer one is the anode. This smaller one is the cathode. So the anode is this guy and has to be connected to positive. The cathode is this guy, has to be connected to negative. The reason for that is just because of how diodes work. So diodes allow current to flow only in one direction, not in the other direction. So it can go from cathode to anode if you're using electron flow, from cathode to anode like this. It cannot go in the other way. If I were to take our little design here, and if I can turn it on, everything works. If I were to just reverse this component, literally just turn it around, nothing's going to happen. There is no current flow, nothing happens at all. It's just sitting there, no love. Of course, if I put it back in, turn the power back on, there we go. So it only allows current to flow in one direction. If current is flowing, normally diodes are made out of like silicon or germanium, and silicon being probably the most common. And here it is right here. It's this little chip. That's the thing that's doing it. This is a little semiconductor block, usually made of, it's not usually silicon, it's usually some fancy semiconductor, aluminum, gallium arsenide or something like that. And so it's connected here to the cathode, and it's got a tiny little wire, a little tiny wire connected here to the anode. And this little element, this lights up. That's what's happening. This guy lights up. So that's how this works. Now, I said this book has photography. So that is what this is. This is an actual photo. Pull this out a little bit. This is an actual super high resolution photo of a cross section. So someone took the LED and just, it's sitting here like this, and they just sliced it like that so we can see the cross section of it. I'm going to zoom way down to the interesting bits. So we have our cathode coming up like this, and this sort of funky shape is just to make it easier to manufacture. So this is the actual element right there. You can see it seated across here, and it has this nice little, you can barely see it, but this little wire here. So that is the actual internals of this LED. There's many different kinds. Here are some surface mounts. Here's a zoomed in view of what they look like. Now it's the same idea. This one's yellow, but you can see the same idea. It's just this sort of resin block with the actual element right there with the little thing going across. Here's another fun one. This one is a bi-directional one. What it does is it allows you to split the anode and the cathode. And so you actually could put this in reverse, and depending on which way you put it in, it'll either be red or it will be green. So there's a red-green bicolor LED, and there's many, many, many different kinds. There's multicolor ones. There's ones with multiple leads, so that depending on which lead you're using, it goes, to different ones. There's a lot of different variants of this. I thought that would be cool to see the internals of the LED. Okay, let's talk about the other piece. This one's interesting because this one I didn't know until, we were sitting there actually doing this. So if I turn this on and I turn this on, right? So I'm turning on this guy. The light stops. Now I don't usually use these types of LEDs, but the book here implies somewhere in here the motor only starts running when the button is pressed. In most cases, however, the flashing stops immediately. This is due to interference generated by the motor. Short pulses on the operating voltage disrupt the function of the flashing LED. We'll find a method to prevent this interference later. Now, I'm pretty sure I know how to prevent this interference, but I want to look at it first. The way that we're going to look at it is by hooking up a whole bunch of fun probes. So give me 1 minute and I'll hook everything up. Okay, so I've hooked up this monster, this sort of monstrosity, but basically I have 2 leads hooked up, this one and this one. This one's the yellow one. They are color coded, so we have a yellow one here and a purple one here. What this does is, I've hooked it up to what's called an oscilloscope. The oscilloscope looks like that. An oscilloscope, very, very briefly, or very basically, measures voltage over time. That's pretty much it. So it lets us look at signals. It lets us watch how signals change and all of that kind of stuff. That's its main purpose. Let me try and get a good shot of this. There we go. So what I'm going to do is I'm going to turn this on. Now the yellow trace, which you can see here, is representing our the total power, the total voltage across the circuit as a whole. So I have it at the top of that resistor. Over here, this purple one, which is all the way at the bottom, that is measuring just across the LED. Here we go. So I've turned it on. I'm going to hit this roll button that's over here, and now we can kind of see it going. This is real time. So what we have here is there's voltages per division. So this little yellow triangle is where we are. It goes up 1 division. You can see the graph, right? Yeah, it looks like you can. And I'm at 5 volts per division for yellow, so that means it's 5 volts approximately, which is what we'd expect. We'd expect it to be about 5 volts. And over here, this guy here, I have this at 1 volt per division. I can drop it down a little bit more to like 2 volts per division. You can kind of see it a little better, right? So low, high, we're watching this. This is perfectly timed with the blinks that we're seeing as this thing is going, low and high and low and high. That's what's going on here. And of course, as soon as I press the button for the motor, we'll see what happens. All of a sudden it stays low. Now you can kind of see it right now, right? Let me let it go. Let me see if I can get a better view of this. I'm going to turn this on. I'm going to try and pause this. Okay, here we go. Ready? There we go. So now that it's stopped, you have a better view of this, I think. You can see that it's not just a perfectly straight line anymore. You see all this yellow crap up and down? That's called noise. So that noise is causing the fluctuations, is causing the issues that we're seeing. I don't know if I can zoom this in a little more. I can kind of zoom it in like that. Yeah, you can really see it there. Okay, I fiddled the camera a little bit, and this slight down angle gives me the best shot of this. This very close-up kind of down angle shot. You can really see the jitteriness here. I'm going to be honest, I don't actually know exactly why it causes it to freak out. If we look at the purple trace, we can see that it's also sort of all over the place, right? How do we solve that? Well, I'm basically 100% sure I know what's happening in the next bit. If you want to be surprised for whatever reason as to what's happening, and I'll probably go deeper into it once we get there, the way to solve that is to filter this noise out. This is super, super, super common. on just about any board that you pull out, on just about any piece of electronics you pull out, you will find components that look sort of like this. This is our friend the capacitor. This is a very simple little sort of disc, like a ceramic capacitor. This is 0.47 microfarads, and I will bet you that if I were to install this, that this would just work. So let me reset the camera for a second. All right, we're back here on the bench. I disconnected the oscilloscope just so I have more working space. Here's our capacitor, this little 0.47 microfarad capacitor. I'm just going to install this right here. I'm just going to put it right there. And let's take a look at the schematic. This is what they gave us. This is their diagram, and they have a wiring diagram that looks like that. So all I did was I put the capacitor directly in the same exact spots that this LED is going. For those who want to see schematics, if we were to take this and redraw it, I would have something like this. Let's see, I would have my battery that would come up like this. I would have my motor, which would come down like this. I would have my switch, which would come down like this. And so this is kind of one leg of our circuit. And then we have our resistor and our LED, which come over like this. And then that's it. These guys are done. And then these are connected, so that needs to get filled in. So we have this. So what did I do? What I did is I added right here a capacitor, and that's what a capacitor looks like. I just literally added that component right there. Let's see if this fixes it. I'm extremely confident that this will fix it. Oh, it might help if I turned on power. There we go. So it's blinking, and look at that. Light stays blinking as I turn on this thing. We have no issues whatsoever. And we're back here at our oscilloscope, so I'm just going to go ahead and turn this on again. We can see some interesting characteristics. I'm going to turn this on, and we can see that while we still get noise across everything as a whole, we don't get it across that purple thing. So there we are. And I realize that I'm being dumb, so let's de-dumb this thing. So before, what I had was you could still see the noise here on the yellow. There's no reason for that. I still get a little bit of wonkiness. It still gets a little fuzzy, but it's not the spikes and pits that we had before, right? This is way better on both sides, and the light is still blinking. Everything's fine. The only difference that I did here is that instead of just, let me come back down here, instead of hooking it up like this, I actually just went across the entire thing, which is of course what I should have done in the beginning, and I'm being dumb for not doing that. But yes, this is the way. This is how you smooth it out. I'm very sure that what they're going to do is give me a capacitor. I don't know what value they're going to give me. I used a 0.47 microfarad capacitor for no particular reason. It's because I happen to pull it out. If I were doing this for real, I would do the math and figure out exactly what frequencies I need to filter, and I'd create a filter for those exact frequencies, like the exact frequency that I'm trying to get rid of. So I'm really curious to see what happens next week. I'm really curious what value they give us and what they talk about in terms of that value. And maybe in the technical video, we'll do some of the math and figure out why that value is the correct value. So that'll be fun. Okay, thanks for watching these. These are super fun to make, but I really appreciate you guys watching them, and I'll see you tomorrow.